It is well known that exposure to lead has numerous adverse effects on behavior and development. Investigations on the effect of early childhood lead exposure on behavioral problems from childhood to early adulthood have been made. I find large negative consequences of early childhood lead exposure in the form of an unfolding series of adverse behavioral outcomes. Behavioral problems as a child, pregnancy and aggression as a teens, and criminal behavior as a young adult. At the levels of lead that were the norm in United States until the late 1980s, estimated elasticities of these behaviors with respect to lead range between zero point 0.1 and 1.0. A growing body of literature argues that social scientists should cast a wider lens by considering early life experiences and environments as potentially important determinants of later life outcomes. Almond and Curie, in 2010, for example, cite abundant results showing that events in early childhood can have long lasting impacts on adult outcomes, largely through effects on development of cognitive and non cognitive skills. Characteristics such as the ability to learn well, to listen, to cooperate, and to be respectful of others are established early in life and are foundational elements of human capital. On the other hand, characteristics such as easy distractibility, aggression, and short temper are counterproductive. There's an emerging consensus that formative early life influences may substantially shape adult behavior and outcomes. Lead is a heavy metal and an important environmental toxic and nerve poison that can cause destruction of many functions of the nervous system. Lead poisoning is a medical condition caused by increased levels of lead in the body. Lead interferes with a variety of body processes and is toxic to many organs and issues, including the central nervous system. It interferes with the development of the nervous system and is therefore particularly toxic to children, causing potentially permanent neural and cognitive impairments. An investigation into the relationship between lead poisoning and the intellectual and neurobehavioral capabilities of children shows that it has dire consequences. Blood lead levels were significantly negatively correlated with the developmental quotients of adaptive behavior, gross motor performance, fine motor performance, language development, and individual social behavior. Compared with healthy children, more children with lead poisoning had abnormal behaviors, especially social withdrawal, depression, and atypical body movements, aggression, and destruction. Lead poisoning has adverse effects on the behavior and mental development of 2 to 4-year-old children. Lead widely exists in the environment and it is a heavy metal element with neurotoxic effects. In contrast to trace elements such as iron and zinc, lead has no known beneficial effects in the human body. With the economic development of China in recent years, the concentration of lead in the environment has increased, and lead pollution has become a serious problem. Chinese people have begun to place greater scrutiny on the influence of lead exposure on human health, especially its impact on teenagers. Lead poisoning can damage and produce irreversible harm to fetal growth, the growth of teenagers, and psychological, behavioral, and cognitive development. Because lead in the environment gradually accumulates in the body, lead is regarded as one of the most harmful environmental toxins to toddlers. When the blood lead level reaches about 50 micrograms per liter in the body of children, it can impair growth, memory, intelligence, and behavior, even when there is no obvious clinical manifestation. The most important untoward effect of lead exposure is the impairment of the intelligence of infants and the learning abilities of children. Most recent investigations have verified that lead exposure can affect learning and memory, and the intelligence quotient of children is inversely proportional to their blood lead levels. Because childhood lead poisoning is quite common in China at present, it should be given adequate attention. Most international long-term follow-up investigations of the effects of lead exposure on neurological dysfunctions in children have reported that these effects of lead are persistent, especially lead exposure in 2-year-old children, an age that appears to be a critical period for a child's later intelligence quotient and academic achievement. There is very strong evidence clearly indicating that lead has a negative influence on children's intelligence and behavioral development. To talk about phthalates, concern exists over whether additives in plastics to which most people are exposed, such as phthalates, bisphenol A, or polybrominated diphenyl ethers, may cause harm to human health by altering endocrine function or through other biological mechanisms. Human data is limited compared with the large body of experimental evidence documenting reproductive or developmental toxicity in relation to these compounds. Here we discuss the current state of human evidence as well as future research trends and needs. Because exposure assessment is often a major weakness in epidemiological studies, and in utero exposures or reproductive or developmental toxins are important, we also provide marginal data here. On maternal exposure to phthalates during and after pregnancy. Phthalate metabolite concentrations in urine showed weak correlations between pre and postnatal samples, though the strength of the relationship increased when duration between the two samples decreased. Phthalate metabolite levels also tended to be higher in postnatal samples. In conclusion, there is a great need for more human studies of adverse health effects associated with plastic additives. Recent advances in the measurement of exposure biomarkers hold such much promise in improving the epidemiological data, but their utility must be understood to facilitate appropriate study design. Advances in material sciences and engineering in recent decades have led to widespread and diverse use of plastics to provide cheaper, lighter, stronger, safer, more durable and versatile products and consumer goods that serve to improve our quality of life. Plastics can be designed to keep our foods fresher for long periods of time, can provide therapeutic benefits through time-release pharmaceuticals and other medical applications, and can prevent electronics and other household items from starting or spreading fires. However, scientific, government, and public concern exists over the potential adverse human health risks related to ubiquitous exposures to plastic additives among the general population. The leading hypothesis for these growing concerns is that certain chemicals used in plastics to provide beneficial physical qualities may also act as endocrine disrupting compounds, EDCs, that could lead to adverse reproductive and developmental effects. In men, environmental or occupational exposures to EDCs may be associated with or led to declined reproductive capacity or possibly increased risk of testicular or prostate cancer. In fact, a number of studies have suggested the use of circulating reproductive hormone levels, the follicle stimulating hormone or inhibin B, as a surrogate measure for semen quality or fecundity in epidemiological studies, although other recent studies suggest hormone levels may lack sufficient ability to predict poor semen quality. Endocrine alterations in women resulting from environmental or occupational exposure may represent increased risk for endometriosis, reproductive and other endocrine related cancers, or impaired oocyte competence, ovarian function, or menstrual cycling. Effects of early life exposures to EDCs remain unclear, though it has been suggested that fetal or childhood exposure may lead to altered sex differentiation. Effects on neurological and reproductive development, and risk of reproductive problems or cancer in life. Programming in early life can determine an individual's future health. Therefore, early chemical exposures may have long-term impacts later on in life. A leading hypothesis for a collection of linked conditions in human males exposed to EDCs in utero is termed testicular dysgenesis syndrome (TDS). TDS represents a number of reproductive disorders of varying severity that are associated with disturbed gonadal development, including cryptorchidism, hypospadias, and smaller reproductive organs. Later in life, the effects of TDS are hypothesized to manifest as a reduction in semen quality and infertility, as well as an increased risk for testicular cancer. Synthetic compounds called parabens are added to toothpaste, deodorants, shampoos, and other products to stop the growth of fungus, bacteria, and other potentially damaging microbes. First commercialized in the 1950s, parabens are a group of synthetic compounds commonly used as preservatives in a wide range of health, beauty, and personal care products. If the product you are using contains methyl paraben, ethyl paraben, propyl paraben, butyl paraben, or isobutyl paraben, it has parabens. These ingredients are added to deodorants, toothpaste, shampoos, conditioners, body lotions, and other makeup products. To stop the growth of fungus bacteria, researchers have also found that some 90% of typical grocery items contain measurable amounts of parabens, which is why even those who steer clear of potentially harmful personal care products also carry parabens around in their bloodstreams.